lesson, we're specifically talking about solving equations with the variable in the exponent. Our first problem is how many 3's would you have to multiply together to get 27? So we're not looking at an equation yet. We just want to think about this concept of the base being 3 and how many times would you have to multiply that 3 together to get another number. So for example, our 27 here, we're trying to get 27. So 3 times 3 would give us 9. So that's 2 3's. And then another times 3 would give us 27. So how many 3's did we multiply together? 1, 2, 3 3's. Okay? So now we can kind of think of this in a different way. What power would you raise 5 to in order to get 625? Okay, so what I'm saying is 5 to what power equals 625? This is the same concept as the problem before it. So for example, if I'm saying how many times would I have to multiply 3 together to get 27, in this problem I could say how many times would I have to multiply 5 together to get 625. So let's see if we can figure that out. 5 times 5 is 25. Times 5 again is 125. Times 5 again gives me that 625. So how many 5's did I have? 1, 2, 3, 4. So this equation that I've created right here would really be 5 to the 4th equals 625. So my answer for this is the exponent of 4. Now we can look at this in this way. 5 to what power equals 625? We can kind of convert this to an equation with x as the variable by saying 5 to the x power is 625. So the x in this equation is the exponent for the base, and the base for this one is 5. Okay, so the answer is 4. And so our answer is the exponent. And if you think about what we've done in the past, we were not able to really do anything with this type of equation, but now we're going to be able to kind of either figure it out just logically, or we can use logarithms to help us figure that out if we don't know how to do that logically. So before we can get to actually applying this with logarithms, we need to know how exponentials and logarithms relate. And those forms can actually be converted back and forth. So we may have an exponential form very similar to what we had just then with the 5 to the x equals 625. And now we've got 3 to the x equals 9. This is called exponential form. 3 to what power equals 9. And instead of saying what power, we're really putting an x there. We're trying to figure out that exponent. Now, we can actually take logarithm is shortcut for log. Actually, log is shortcut for logarithm. And an important thing to note here is that this 3 in the exponential form is considered a base, and that this 3 in the logarithmic form is also considered a base. So when you're converting from an exponential to a logarithmic form, you want to make sure that this base is the same as this base. Now, what do you notice about the other two things? So you've got an exponent here, and then your answer. And if you notice when you look down here, the exponent ends up being what the logarithm is equal to. And the answer goes over here on the left side. So one important aspect of logarithms is that your answer is your exponent. So let's look at just converting between the exponential and logarithmic forms. So we're not trying to actually figure anything out. We're not trying to find the value of x. We're just rewriting things to practice that. Later, this practice of rewriting things will help us solve the logarithmic and exponential equations, but we're not there yet. So right now we're just going to practice rewriting. So we have an exponential form, and we want to change that to logarithmic form. So if we're changing to logarithmic form, we're going to start by writing log. The next thing you want to find is the base. So the base in this problem was the 4, the base of an exponential. And the way you write it is it's a subscript. So it is a little bit below the regular line. And then think about what happened up here. The exponent was what it was equal to. And then the answer ended up going on the left side right after the base. So our answer here was 16. We're going to write that first. And then we're going to set it equal to the exponent of x. So all I've done is rewritten this exponential equation to a logarithmic equation. Okay? Our next step is to continue to do this. Now, what do you notice about these things? These exponential equations may not always have x in the exponent. So just be mindful of that and make sure you put your variable and your answer and your exponents all in the correct place when you're rewriting things. Okay? So again, we're going to write log. Our base is 2. Our answer here is x. Some people also call that the argument. Equals the exponent of 3. So on this one, I'm going to show you what I consider just kind of an easy way to think about this. It's not really a shortcut. It's just a way to kind of remember what order this goes in. So I start with writing log. And then I start with the base here, and then if I do a backward C, like the letter C, motion with this, it will show me the order in which I need to do this. So I've got 3 log base 3 of 27, and then that's going to be equal the exponent of x. So let's write those numbers in that order. Log base 3 of 27 equals x. Log base 3 of 27 equals x. Okay, let's try that same thing with this one. Log base x of 729 equals 6. So you're going in a backward C. All right, so that was changing from exponential to logarithms. Let's now do the reverse. So we're changing from logarithmic form back to the exponential form. So you're always going to start with your base. So what is our base in 4a? It is 3. So that now becomes the base to an exponential equation. And in the same way that we did this, that same thing applies. The backward C motion still applies with this. So it's going to be 3. And if you remember, the logarithm equals the exponent. So this is going to be 3 to the 4th, and then that's going to be equal to x. Again, we're not trying to find the answer here. We're not trying to find what x is. We're just rewriting. Okay? Don't solve. B, start with your base of x. Your exponent's going to be 2, and it's going to be equal to 49. Same thing here with C. Notice I don't have logarithm here. This is just exponential form. It's already in log form. We're just changing. So that means you're taking the log away. Start with 7, raise to the x power, set it equal to 343. And last but not least, 4 to the x equals 1024. So all I did was rewrite from logarithmic form to exponential form. You will see in the next lesson that this becomes very helpful in solving logarithmic equations, and changing it back and forth can also help us solve exponential equations.